Let's see this case. Find the accelerations A1, A2 and A3 of three blocks as shown in figure. If a horizontal force of 10 Newton is applied, A on 2 kg, B on 3 kg and C on 7 kg, take G is 10 meter per second square. So this kind of a problem is typically called three block problem. And it's a very lengthy problem, so be patient with it. The A part says these are the friction coefficients between these two blocks. Now, the first thing is, let's say we take the A part. The A part has these three blocks like this, and the three blocks, one like this, second like this, the third one like this, are kept one at the top of the other. This is 2, this is 3, this is 7, where a force of 10 Newton acts on it in the forward direction. The first surface is mu is equal to 0.2 and the second surface has mu is equal to 0.3, while the third surface over here is smooth. Now, firstly, we'll have to check the normal reactions at each surface. If I see the 2 kg block, on the 2 kg block, 2g would act downward and n1 would act upward, so that they don't move in y, so n1 has to be equal to 2g. Now if you see the 3 kg block, every action has its equal and opposite reaction, so n1 would act downward, 3g would act downward and n2 would act upward, so that n2 must be n1 plus 3g, which is equal to 5g. So first normal reaction is 20 and second normal reaction is 50. At the surface mu1 is 0.2. So Fs1's maximum value is mu1 n1, 0.2 into 20. This comes out to be 4. And Fs2's maximum value is actually mu2 into n2, which is 0.3 at this point. And the normal reaction is 50. So this has to be 15 Newton. These are the maximum possible values of friction at surface 1 and surface 2. Now let's see them case by case. Now, three block problem cannot be solved directly. You have to form cases on it. Since the ground is smooth, so the system cannot be at rest. The first case possible over here is that, let's case 1, let's check if all of them move together. If all of them move together, take the system over here. Take the system over here. And let's say if all of them move together, then they'll move forward with an acceleration equal to a. Now, no, there are certain frictions between 2 and 3, then 3 and 7, but those frictions are internal and we do not consider internal forces for a system. Now, if we don't consider internal forces for the system, the net force over here is 10. This should be equal to mass into acceleration. So 10 must be equal to mass 12 into acceleration A. So acceleration A must be 10 by 12, which is 5 by 6 meter per second square. Now, if this is the acceleration, let's check whether it is possible or not. See, this is the 2 kg block, this is the 3 kg block, and this is the 7 kg block. This is 2, this is 3, this is 7. On first block, 10 Newton would act forward, which would try to slip forward. So friction in the first case would try to slow it down. And every action has its equal and opposite reaction. So if this first block gets Fs backward, the second block would get Fs1 forward. Now this Fs1 tries to drive second block forward, so the other surface is also rough, so we will get Fs2 backward. And since every action has its equal and opposite reaction, you'll have Fs2 forward over here. With a complete system, I am assuming is moving with an acceleration a and a. So let's check the value of Fs1 and Fs2. 10 minus Fs1 is mass 2, acceleration 5 by 6, which is 5 by 3. So Fs1 is 10 minus 5 by 3, which comes out to be 25 by 3 or 8.33 newtons. And let's just check for Fs2. Fs2 would be mass into acceleration from this diagram. Mass is 7, acceleration is 5 by 6. So that's 35 by 6, which is basically roughly 5. 5 by 6 can be written as 8, 5.83, roughly this much Newton. So Fs1 required is 8.33 and Fs2 required is 5.83. But if you check their maximums, Fs1 maximum was 4, and if you check this maximum, Fs2's maximum was 15. So this cannot be fulfilled. If this over here cannot be fulfilled, that means there would be slipping at the surface. So the next possible outcome over here, that is the case 2, is that see, the first surface had a slipping. So let's say 2 kg moves separately, but 3 and 7 move together. Let's see that situation. If I say that 2 kg moves separately over here and 3 and 7 over here move together, so this is 2, this is 3 and this is 7, and I can take them as a system where 10 acts forward on it, and since over here they move separately, so friction becomes kinetic, and kinetic is equal to mu into n, which we calculated as 4. And every action has its equal and opposite reaction, so over here friction's value would be 4. Let's say the upper block moves with an acceleration a1 and lower system moves with an acceleration a2. So 10 minus 4 must be equal to mass 2 into acceleration a1, or 6 must be 2a1, or a1 must come out to be 3 meter per second square. And Fk, that is 4, there would be a friction over here, that is Fs2 and Fs2, but as you can see, that's internal. We don't consider the internal forces. The external forces 4 must be acceleration, mass 10, acceleration a2. So acceleration a2 would come out to be 0.4 meter per second square. Now see the setup. This is a 3 kg block. This is a 7 kg block. On this 4 acts forward, Fs2 acts backward, and on this Fs2 acts forward, where Fs2 can be written as 7 into A2 or 7 into 0.4, which is 2.8 Newton. And the maximum value of 2 was, as calculated at the top, it was 15 Newton. So this is under it. So over here we'll have no slipping and everything is perfectly fine. So upper body would move with 3 meter per second square and the lower bodies would move together with an acceleration of 0.4 meter per second square. These are the answers for the part A.